All right, so in this video, I'm just going to quickly talk about, what's the angle of elevation, what's the angle of depression, and so um, here's my stick figure drawing of a person, right? If he has a line of sight right here, this dashed line is a horizontal line of sight, and this person is standing on some kind of cliff. This is also the horizontal, or line of sight. Well, as you can tell right here, if I were to draw a line from here to here, okay, this angle that's formed from the horizontal, which is the line of sight, to this other person who also has some kind of line of sight, this is called the angle of elevation. Okay, that's just the definition, right? The line of sight from this person to that person's line of sight is some kind of angle that's formed, and that angle is called the angle of elevation. Now, from this person's reference point, who's looking down at this person, he or she also has a line of sight, right? And the angle that's formed between this dashed line and this dashed line right here, this is called the angle of depression. Okay, this is called the angle of depression. Okay, so that's just the terminology that people use in reference to the line of sight. Okay, all right. Now, one thing you learn, right, in Math 1 is that whenever you have two lines that are parallel, right, because this is horizontal, these lines are actually parallel. And think of this as your transversal. Well, what's true about the angle elevation or angle depression? These guys are alternate interior angles, right? So just to abbreviate, I'm going to say AOE is actually congruent to AOD. Angle of depression is actually equal or congruent to by alternate interior angles. Okay, so that's just a quick overview of angle of elevation, angle of depression, and just know that know the terminology, know how to be able to draw the picture, and know that they're essentially the same angle because these lines are parallel. This is the transversal that cuts through those parallel lines. These angles are congruent, therefore. Okay. All right, so let's just do one word problem here. It says a pilot is looking at an airport from her plane. The angle of depression is 29 degrees. If the plane is at an altitude of 10,000 feet, approximately how far is it from the airport, and what is the horizontal distance to the airport? All right, so we need to draw a picture, right? So let's say the plane is right here. Okay, and the angle of depression is 29 degrees. That means from the plane to the airport, here's the airport. And I'm just going to draw a straight line from here to here. The angle of depression, right, is this guy right here. This is 29 degrees. Okay, this is my AOD. All right, now it says the plane is at an altitude of 10,000 feet. That means when you talk about altitude, altitude is just the vertical distance, right? So this plane is 10,000 feet from the ground, basically. And now I can form a triangle. Okay, now what is the question asking? It's asking, how far is it from the airport? So that question, in my opinion, I mean, I copied this problem from the geometry book, is a little bit vague. So that's why I added a second question. What is the horizontal distance to the airport? Well, when you see the word horizontal, right, it just means a straight, right? Basically your x-axis. This would be the horizontal distance. So back to this question, right? Approximately how far is it from the airport? They're asking you to figure out what this is. We'll call this R, okay? So you have your trig ratios. Now, this 29 degrees is technically this angle right here, right? But if this is 29, that means this angle right here is 29. All right, again, this is your alternate interior angles at work here, right? If this is 29, which is my angle of elevation, this is or sorry, angle of depression, this is my 29 degrees, which is technically my angle of elevation too. So again, the key is to draw the picture correctly. If you don't draw the picture correctly, right, you might solve, you're going to solve it incorrectly, even though the problem itself is just a basic right triangle. Okay, so let's figure out part A. If we want to solve for R, and this is 29 degrees, we don't know what this is, but in relationship to this 29, right, I have a side that's opposite, and I have the hypotenuse. So I'm going to use sine, my sine ratio. Sine of 29 is equal to opposite of hypotenuse 10,000 over R. Okay, and then of course you can solve, right, by cross multiplying. R sine 29 is equal to 10,000. R is equal to 10,000 divided by sine of 29. Okay, so that's the exact answer, right, in feet. But to get the approximate answer, you would just use your calculator. 10,000 divided by sine 29. Okay, so it looks like you're going to get 20,626 feet. And to figure out part B, right, what's the horizontal distance? If I want the horizontal distance, which would be x, right, this side right here is adjacent to the 29, right, it's next to, so I would use cosine. Or actually, not quite, I wouldn't use cosine because I don't know what R is. Actually, you could use cosine if you want because this is 20,626.6 feet, but I'm just going to use this, okay? So if I have a side that's opposite to the 29 and I have a side that's adjacent, right, I'm going to use tangent. So tangent of 29 is equal to 10,000 over x, right? And then get x by itself. Okay, so x would just equal, I'm going to skip a few steps in the cross multiplying. X is equal to 10,000 divided by 1029. Okay, so 10,000 divided by tangent of 29 is approximately 18,040 feet. Okay, so the key right here, right, is to be able to draw the picture. And once you draw the picture, right, you're able to figure out, oh, do I use sine, cosine, or tangent?